Good morning, everyone. First of all, thank you for taking your time out and coming here for this presentation. I'm Gururaj from VMware, working as a staff engineer there. So today's presentation will be talking about hybrid cloud configuration and how to do the day-to-day operations via API and CLI ways. So here is a quick disclaimer. I'm sure by now you have seen multiple times, right? I'll not spend any time here. Here is the agenda. So first we'll start off with a quick introduction to hybrid cloud. Later we'll see what are the ways to do hybrid link mode configuration and how to do. Followed by we'll see provisioning operations via API and CLIs. Finally, we'll look at how to do migrations using Hcx. Hybrid cloud describes the use of both public as well as private cloud platforms working in conjunction, right? So it basically offers customers the benefits of both worlds, private as well as public cloud. With that, right, customers have an option to choose which type of cloud platform they would like to go with, right? For example, private cloud could be chosen if you want to keep the data more secure, right? Whereas public cloud could be chosen to add more computing resources, storage resources, network resources quickly to temporarily address the surge in demand, right? So in this diagram, to your right-hand side, private cloud front, you have on-premise data center that is deployed with VMware vSphere, which consists of VMware vCenter server as well as ESXi. On your left-hand side, we have VMware SDDC comprising of VMware vSphere, NSX, vSAN sitting on top of AWS global infrastructure, which we call it as VMware on cloud. With such a setup, hybrid link mode configuration is established between on-premise vCenter server and the cloud vCenter server, right? This we call it as hybrid infrastructure. Right? So let's look at how do we do the configuration between cloud and on-premise data center, right? So basically two ways. One is you initiate the connection from the cloud side. The other one is you initiate the connection from the on-premise side, right? We'll go through each one of the ways via APIs and CLIs in next few slides. So let's see how do we initiate the connection or the configuration from the cloud side. Before we actually look into the API or CLI ways, here is a prerequisite for initiating HLM from cloud side. It talks about what should be the on-premise version, what all firewall ports that needs to be open, management gateway that needs to be up, NTP service, so on and so forth, right? With this prerequisite, let's look at the first way of doing the HLM configuration. It is through API Explorer. It basically gives you access to the API service endpoint wherein you can execute the REST APIs, right? By passing in various parameters, you can do the HLM configuration. The screenshot here shows the HLM methods that are available through API Explorer. Let's look at each one of them. Right? First one is establishing the configuration from cloud to on-premise side, right? So post HVC links is a call which takes in the spec as a parameter. Let's look at the sample spec. So the spec, right, to your right-hand side, I passed in the on-premise data center detail consisting of what are the PSC host name, what are the credentials, what port the PSC service is up and running, with what admin group this HLM configuration needs to be associated with, so that once any user who's part of the admin group logs in, he should be able to see on-premise as well as cloud data center in a single pane of glass view, right? So with the spec, if we execute the post HVC links call, if everything goes well, you would be returned with a string response that stands for HLM link ID. Right? Validating HLM link, if there's any existing link between on-premise and cloud data center, you can execute the get HVC links call, which returns you a complex data object consisting of the link, which stands for your HLM link ID, and then the display name, which stands for on-premise domain. Right? If there's no existing link, right, here the response typically would be null. So let's look at how do we delete the existing HLM configuration link, right? So delete HVC links is the API which takes in the link ID, which exact HLM link ID we would like to delete, right? So we'll have to pass in the link ID. Typically the API is designed in such a way that if it doesn't return you anything, if the response code is 200, that means the delete API call has been able to delete your HLM configuration successfully. Additionally, to assure yourself that link configuration is deleted, you can invoke one more API which validates the existing link, right? If the response is null, you can be assured that link has been deleted successfully. And then we looked at the API Explorer way, which is like typical API way of doing the configuration. Now let's look at how do we do the same operations using CLI way. We have two CLIs, one is DCLI and Power CLI. DCLI stands for Data Center Command Line Interface, which is a simple Python-based interface which comes in scriptable mode as well as interactive mode, which you can use to monitor or manage your cloud infrastructure as well as a VMware vSphere on-premise data center. Power CLI, as we all know, it comes with rich commandlets using which you can again manage VMware Cloud on AWS as well as vSphere environment, right? So this screenshot shows from where you can download the latest versions of DCLI and Power CLI for managing VMware Cloud on AWS as well as hybrid cloud. So let's look at the DCLI, what are the commands that are available within DCLI specifically for doing the HLM configuration, right? Here is a sample usage command wherein I have passed the Cloud vCenter server detail. It is telling me create, delete, list are the three commands which are available for doing the configuration. Let's look at each one of them, right? For establishing HLM, create is the command. Here is the sample usage of the command, and then here is the actual execution wherein I have passed what is the Cloud vCenter server I want to connect to, and then from that Cloud vCenter server to which on-premise data center I want to do the HLM configuration, right? Here I've passed the PSE host name, credentials, thumbprint, domain name, and the groups, right? If the command execution is successful, you would be returned with a string response that again stands for HLM link ID. Right? Similarly, for validating any existing HLM link, here is a sample usage of the command. List is the actual command, right? So here is the actual invocation on a Cloud vCenter server. It has returned a complex data object consisting of link ID and the display name, which stands for on-premise domain name. Similarly, for deleting existing HLM configuration, here is the sample usage. Delete is the call to which we'll have to pass the link ID that needs to be deleted. And here is the actual invocation on a live setup, right, wherein we have passed the existing link in the form of string, right? So if everything goes well, you would be returned with a null response, which means deletion is successful, right? Additionally, you can do a list command and see that the actual existing HLM link is null. It doesn't exist. So through Power CLI, we have basic commandlets. Connect CA server actually connects to the server that you want to establish connection with, right? In this case, we will connect to the Cloud vCenter server. The next one, the get CA service, gives you the client stubs, which represent the server-side objects, using which you can execute all the HLM configurations that you need to do from cloud side, right? So let's look at how we can do the HLM configuration from the Power CLI. First, we will connect to the Cloud vCenter server. If command execution is successful, it tells to what Cloud vCenter server it has connected to, and then with what username, and then at what port, right? So get CI server gives you the authenticated client-side stubs. Specifically, I've invoked HVC links related stubs. So we will create a spec through which we will pass what are the on-premise data center details. Here we will say what are the PSC details, admin groups, thumbprint, so on and so forth. Then we will invoke the create commandlet by passing in the spec, right? If everything goes well, you would be returned with a string response which stands for HLM link ID. If there is any error with establishing connection, so on and so forth, that error would be returned here. And then validating HLM, list is the commandlet, which again returns you the complex data object consisting of link ID as well as domain name, right? Which we have to parse. Similarly, deleting HLM link, delete is the commandlet to which you have to pass the existing HLM link ID, and typical response is a null response, which means that configuration has been deleted successfully. So how do we do the same operation through vSphere Automation SDK? We've seen API Explorer, we've seen DCLI, we've seen Power CLI, now vSphere Automation SDK. What is vSphere Automation SDK? Just a quick intro. It's a software developer kit which comes with client libraries and samples which represent the REST APIs, right? Which you can programmatically invoke with various programming languages such as Java, Python, Perl, so on and so forth, right? So for establishing HLM, create is the API call which takes in the spec as an argument. In turn, the spec offers you multiple methods using which you can pass the on-premise data center details, right? Let's look at the Java code snippet on how can we do the HLM configuration. So first we will create a session with the server by authenticating the user and getting the authenticated stubs that represents the HLM configurations, right? So once we're able to get the authenticated stubs, we will create a spec so that we will specify with what on-premise data center we would like to establish connection with, right? So once the connection, once the spec is ready, we will invoke the create API, create REST API by passing in the spec. If everything goes well, it returns a string object which stands for the HLM link ID, right? Similarly, for validating any existing hybrid cloud link, list is the API call. Within that, get link gives you the link ID, right? So same operation here. First, we will establish a session with the server to get the authenticated stubs. Once that call is successful, we'll execute the list API call, which returns us the complex data object. Get link in specific gives us the link ID, and then the display name, which gives you the domain name of the on-premise data center. So same operation. Here, how do we delete the HLM link? Delete is the API call. Again, we'll do the session establishment, getting the client stubs, and then executing the delete API call by specifying the link ID that needs to be removed. So until now, we saw how do we do the configuration from connecting to the cloud side. Now let's look at how do we do the same operations from the on-premise data center side, right? For which you would need a cloud gateway appliance. It's like additional step that you have to do, right? You'll have to download the appliance onto the on-premise data center and then do the configuration. So this snapshot shows you from where you can download the appliance, right? So let's look at the prerequisites for deploying the appliance. Again, it talks about what is the minimum supported on-premise version details, what all firewall ports needs to be open, and then what is the host resource requirement for deploying the appliance itself, right? So once these prerequisites are taken care, let's look at what is the procedure to deploy the appliance itself, right? We'll have to prepare the JSON template for installing this appliance onto the on-premise data center, right? We'll quickly look into the template in the next slide, but for now, let's look at assuming that template is ready, right? Assume the template is ready. What we'll do is copy that template onto the working directory, and then do a installation pre-check just to ensure that your data center, on-premise data center, is capable enough to hold the cloud gateway appliance, right? So installation is, pre-check is successful, and then do the actual installation. Here is the command which will actually deploy the cloud gateway appliance onto the data center, and then it does some configurations before you go ahead and start with the configuration, right? So once it is done, your appliance is up and running on the on-premise data center side. You can log into the appliance and follow any of the methods that we discussed previously, like API Explorer, DCLI, Power CLI, so on and so forth, right? Through the Cloud Gateway appliance, now it is sitting on the on-premise data center side, right? So here is the template, sample template, wherein we will specify to what on-premise vCenter server we would like to deploy the appliance, on to what ESX host, onto what target data store, right? With what network the appliance needs to be associated with, so that once deployment is complete, appliance available as in the network, right? And then what type of disk provisioning with which the deployment, the appliance needs to be deployed. So network configurations, operating system passwords, right? And then more importantly here, the last block wherein we'll specify the on-premise PSC details, platform service control details, with which the appliance will be associated with right after powering on the appliance, right? So with this template, we will do the deployment, and Cloud Gateway appliance will be ready, and then you can follow API Explorer, SDKs, DCLI, and POS-CLI to establish HLM configuration with on-premise as well as cloud data centers. So let's look at some of the provisioning operations that we can do in a typical hybrid cloud. So here we will be discussing about POS-CLI, vSphere Management SDK, which is predominantly SOAP-based SDKs. And then we'll look at content onboarding assistant, which helps you transfer some of the files from on-premise to the cloud data center. So let's look at some of the APIs which we'll be using in POS-CLI as well as vSphere Management SDK. Here we'll be looking at migration, relocation, and clone operations. First one is locate VM task, which helps you to migrate the virtual machines, power on as well as power off, basically hot migration as well as cold migration between on-premise and cloud. So here is the API spec, which describes what virtual machine that needs to be moved, what is the locate spec, right? And then with what priority the virtual machine needs to be moved. Right. The relocate spec talks about to what data store, to what host, to what pool, you would like to move the virtual machine to. And the more important, the one important parameter here is the service locator. Assume that you're migrating the virtual machine from on-premise to cloud. The service locator here captures the details of the cloud vCenter server to which you would like to migrate the VM from, right? From on-premise to the cloud vCenter server, right? So this spec talks about with what priority you would like to migrate the virtual machine with. Similarly, clone operation, it takes in 4 parameters: what virtual machine you would like to clone, and what is the name of the virtual machine, what is the virtual machine clone spec, so on and so forth. So let's look at how do we do the migration or relocation operation using POS-CLI commandlets, right? First, we will establish connection with on-premise VC as well as cloud vCenter server. Then we will get the reference of the source virtual machine that we would like to move. Get the reference for the data store, resource pool on the cloud vCenter server to where we would like to move the virtual machine to. And then get the reference of the destination host. Get the information about the Ethernet devices of the virtual machine so that you can do the network mapping later. And then construct the virtual machine relocate spec by passing in all these details, right? And then we will construct the service locator of the destination cloud vCenter server. Here I pass the credentials, URL, instance UID, thumbprint about the of the cloud vCenter server, right? And then here I'll do the network mapping so that once the VM is migrated to the cloud, it stays in the network, right? And then eventually I'll invoke the relocate VM task by passing in all these details, right? It returns your task reference using various vSphere task APIs. You can monitor the progress of the relocate VM task, right? So similarly, clone operation, the same operation we would do, getting the references of all the virtual machine, data center, data store, ESX and all. Create a virtual machine clone spec, pass in all the details to the location spec, construct the service relocator, set the device change, basically do the network mapping here, and then invoke the clone VM task by passing in all these information, right? Again, it returns a task reference you can monitor to know the progress, right? So how to do the same operation using vSphere Management SDK, right? So we will get the reference for the source virtual machine, networks, service relocator, and all of the details that are needed to do the migration. Construct the locate spec by passing in all these details, and then eventually invoke the locate VM task API by passing in all these details. Again, it returns a task reference, which you can monitor to know the progress of the task. Similarly, clone operation, right? We will construct the virtual machine clone spec in addition to the relocation relocate spec, wherein we'll specify what needs to happen after the virtual machine clone is done. Whether we would like to power on the virtual machine, and whether it's the template that we are cloning or the typical virtual machine that we are cloning, right? Then construct the virtual machine relocate spec, and then invoke the clone VM task, right, by passing in all these details. After this, the clone VM task starts off. You can monitor the progress of the clone using the task reference. Right. Quickly on the content board assistant, the screenshot shows from where you can download the content onboard assistant tool. It basically helps you to transfer your template files, OVF files, some of the script files or other files that you might have on the on-premise side onto the cloud data center. So this tool works on the principle of content library feature, if you're aware of it, right? So it creates a published library on the on-premise data center and moves the files over there. And on the cloud data center, it creates a subscribe library and does the sync. That way you'll get the files which were there on the on-premise onto the cloud data center. So here is the sample usage of the content onboard assistant tool. The screenshot shows various options that are available. So let's look at one of the example wherein we will try to transfer OVF files from on-premise data center to cloud data center. Right here, I have specified what is the on-premise server details, what are the admin password, credentials, to what cloud server I would like to transfer the virtual machines to, and which data store I would like to scan for the OVF files. Right. So it asks for the credentials, enter the credentials, then it does the connectivity check between the client and on-premise server as well as cloud data center, and then it scans for the templates folder. Since this specific example is about OVF files, here it didn't find anything on the templates directory. So it scans for the data store that we had given. It has found one OVF file, which corresponds to one virtual machine, the 3 files. Now it creates a published library on the on-premise side, right? And then imports all those OVF files into the published library on the on-premise side. And then it creates a subscribe library on the cloud side and does the syncing. This way, you would have all the files that were available on the on-premise side onto the cloud side. Okay, so quickly you're moving on. Let's now look at how do we do the migrations using Hcx, right? A quick intro on the Hcx. Hcx basically allows customers to freely migrate workloads across multiple on-premise data centers as well as VMware Cloud on AWS. Right here, as you can see, you can migrate legacy VMs as old as vSphere 5.0 from the on-premise to your cloud. At the same time, you can migrate some of the virtual machines from other hypervisors like KVM or Hyper-V into your cloud, right? So this Hcx works on the basis of pairing concept, site pairing concept. On the on-premise side, you would have Hcx Enterprise Manager, and on the cloud side, you would have Hcx Cloud Manager. These, both these, sites will be paired along with other appliances such as, interconnect appliance, WAN optimization appliance, and network extension appliance, which will truly enable the workload migrations between the cloud and on-premise data centers, right? So this way, what happens is, right, you can do let's say bulk migrations, vMotions, and operating system assisted vMotion, replication based vMotions seamlessly between your on-premise and then cloud. Right? So now let's look at how to do the Hcx migration via 2 ways. First, we'll look at API Explorer and then the Power CLI way. Here is a screenshot which shows what are the methods that are available for doing the migration operations, right? Here we have connected to the on-premise side, which is basically Hcx Enterprise Manager. So let's look at the first call, which is a create API call. It's basically tells our intent to do the migration, right? For which let's look at how a typical sample request looks like. We'll have to tell what type of migration we would like to do, and then what VM we would like to migrate to, right? And then we will specify what is the source Hcx site details, what is the destination Hcx site details, and then the placement on cloud vCenter server on cloud side to what data center, what workload, what resource pool we would like to migrate the virtual machine to, and then with what network the virtual machine needs to be associated with once it is in the cloud, right? And then storage to what specific data store on cloud the virtual machine needs to be migrated to, and then decision rules basically captures after the virtual machine is migrated what you would like to do before the virtual machine is powered on. Do you want to upgrade the VM tools? Do you want to upgrade virtual hardware? Do you want to forcefully power off VM? So on and so forth, right? And then schedule. Schedule failover basically comes into picture when you're trying to switch the virtual machine from the on-premise into the cloud, right? So since we're talking about simple vMotion, I've set the this field as false, right? With this spec, we have shown our intent to do the migration, right? So if everything goes well, you would be returned with a migration request object ID, right? So how do we start off the actual migration, right? Start is the API call to which the same spec we will pass in the migration ID, which will kickstart the actual migration from on-premise to the cloud. Right? So migration is started off. How do you query? How do you know the progress of the migration task, right? Query is the API call. Here we'll have to pass in the filter saying what is the migration ID, what is the virtual machine that that is getting migrated, and what is the migration type, right? With this sample request, the typical response would look something like this, which captures what is the state of the migration, what is the progress percentage. In this case, progress percentage is 98, which is almost like done with the migration task, right? So now let's look at how to do the same operation using Power CLI, right? Power CLI again offers the commandlets. The first commandlet is a new Hcx migration. Again, it's our intent to do the migration. We are not actually doing the migration. We're just saying, I'm planning to do the migration, right? For which you'll have to pass in what is the source side, destination side, network mapping, data store, what is the virtual machine that you want to migrate, right? All these details. And then test Hcx migration validates if there are any errors with the with your intent to do the migration, right? Again, we will pass in the migration request ID to the test Hcx migration commandlet. If there are no errors, you can actually kickstart the migration by using start Hcx migration by passing in the migration request object ID. Right? So let's look at how the flow looks like for doing the Hcx migration through Power CLI. Right? First, we will connect to the Hcx server on the on-premise side. Basically, we'll be connecting to the Hcx Enterprise Manager. Here, we'll be passing in the credentials and the server address. Then we will get the reference to the source site as well as destination site, get the reference to the virtual machine, and then compute resource pool on the destination, and then on what data store we would like to migrate the virtual machine to, then do the network mapping, and then the first command, new Hcx migration, our intent to do the migration, it returns you a migration request object ID, right? Then validate the migration, basically do the pre-check by passing in the migration request object ID. If there are no errors, you're good to go and kickstart the migration. Start Hcx migration is the one which will start off actual migration, right? Once the migration is started off, you can use get-hcx migration to know the progress of the migration task. All right. So to summarize, HLM configuration, we've seen the two ways to do it, one from cloud side, the other one from on-premise side using Cloud Gateway Appliance. We have seen how to do the HLM configuration via API and CLI. We discussed API Explorer, DCLI, Power CLI, the SDK, CLI installer. And in the provisioning operations, we have looked at relocate and clone APIs, and then used Power CLI, management SDKs to do the operations. And then content onboarding assistant, we have seen how to transfer your files from on-premise to cloud data center. And in the Hcx migration, we have seen through API Explorer and Power CLI how you can do bulk migration, vMotion, or operating system assisted migration, so on and so forth. Right? So please fill out your survey. Please give the feedback. Right? So I'll be around for any questions. Thank you.